So here's another question. I want us to attempt it together and see whether it's workable or doable. So in this case, I'm having this question. A certain two-digit number is equivalent to 5 times the sum of the digits. It is found to be less 9 than the number formed when the digits are interchanged or rather reversed. You're told to find the original number or find the number. So in this case, I first make a representation of what has been explained up here. You're told, I assume that my number is xy. And we are told xy is equals to 5 times the sum of the digits. So we have it at that. So in this case, we can now expand this one, that you can have xy is equals to 5x plus 5y. Now, I can even also write this number in terms of the place value. So this one is in the ones and this one is in the tens place value. So at this point, we're going to have 10x plus y should also be equal to 5x plus 5y. So I trust we are together. So in this case, I put the like terms together and I'm going to have 10x minus 5x plus y minus 5y is equals to 0. I equate that whatever to 0. So in this case, I'm going to get 5x plus, this gives me 4y. 4y is equals to 0. Higher. So this forms our first equation. Let me now represent the second part of the question whereby we are told it is found. Okay, fine. Sorry. Let me rectify here. So it's supposed to be negative at that point. So that forms my first equation. So in the second one, we are told that now xy, the number xy, is equal to the reverse of this number, which is yx minus 9. So I'm also going to write these values in place values. So I'm going to have 10x plus y is equals to 10y plus x minus 9. That is another equation formed. Allow me put the like terms together. So in this case, I'm going to have 10x minus x plus y minus 10y is equals to minus 9. So this is the second, I'm representing the second part of the question. So in this case, I'll be having 9x minus 9y is equals to minus 9. And because these values here are common, I can divide by 9 by 9 by 9. So at this point, I'll have whatever remains now will be x minus y is equals to minus 1. Right? So from this point, we can be able to get the value of x by making it the subject of the formula. So at this point, I'll be having x is equals to minus 1 plus y. Yes, I believe we are together up to that point. So I'm going to pick my first equation. I'll use the equation up here, or either of the equations formed, to get the value of y now that we have the value of x. So in this case, I'm going to take 5, this equation right here. But now we have the value of x as negative 1 plus y minus 4y should be equal to 0. So I open the bracket here. I'm going to have negative 5 plus 5y minus 4y is equals to 0. So minus 5 minus 5. So what is 5 minus 4 is equals to 1. So plus 1y is equals to 0, or rather you write y. So minus 5 is equals to 0 minus y. So of which now in this case, I'll be having negative 5 is equals to minus y. So the value of y, I divide by negative, I divide by negative. So y is equals to 5. We already have the first value of y, which is that one. So allow me underline here and proceed with the question on this other side. We have now the digit value of y to be 5. So from this point now, we can be able to get the digit value of x. So in this case, I'm going to use this simple equation here, which is, we said x minus y should give us a -1. But at this point now we have the digit value of y. So I'm going to have x minus 5 should give me -1. So x is equals to -1 plus 5. After I take now 5 to this other side, so x is equals to 4. So xy is equals to 45. And the reverse of that number, though we are looking for this number, but the reverse of this number is what? Is 54. You can use the information above to confirm the working or whether the digits are correct.